is Florida State University. My secret to success.
The following is a presentation of the Florida State University Communications Group.
Coming up on this, the story of Jack and the Beanstalk could come to life with the world's most powerful magnets. From university lab to the marketplace, higher education is cashing in on faculty inventions, university-based research, and here's your host, former NASA astronaut and 5-time space traveler, Dr. Norm Thaggart.
Hello, and welcome to another edition of Eureka, a program celebrating the university's role in searching for solutions to the problems of today and tomorrow. If you're like most people, your only use of magnets consists of placing them on the refrigerator door. But as we hear from Erica Ingleson, scientists are cultivating new uses for the world's most powerful magnets.
Imagine if your plants and vegetables could germinate twice as fast as they do now. This could soon become reality, thanks to the research of Florida State engineering professor Dr. Qing-Jeng Chen, who has been conducting research to determine the effects of powerful magnets on plant life. Chen has been working with magnets for the past 4 years and has found that they dramatically affect the speed of plant growth. Chen and his colleagues conduct their research at the National High Magnetic Field Laboratory, the only user facility of its kind in the Western Hemisphere. The laboratory develops and provides a variety of research magnets at the highest fields available in the world. Using a 1.5 Tesla magnet, which is 30,000 times stronger than the Earth's magnetic field, Chen exposed plant and vegetable seeds at different time intervals. In addition, he used a control group of seeds that were not exposed to the magnets at all. The seeds were then planted, and after several days, Chen found that the seeds exposed to the magnets grew more rapidly than those not exposed.
It's just very obviously they are growing twice, 3 times faster than those non-exposure ones. And so we have evidence to show that some optimal exposure to the magnetic field will grow best.
For example, a bean seed exposed to the magnet took just 45 days to germinate, flower, and produce pods, as compared to the 70 to 80 days it normally takes. More research is necessary before determining what causes the accelerated growth, but Chen believes a possible explanation is that the magnet alters the membrane structure of the plant, therefore allowing more water into the seed and encouraging germination. But what could this do for a person in the horticulture business?
Our juniper propagation, to be able to speed that up a little bit, because we have to wait on it a lot of times to root longer than the other material, which we could be able to schedule potting it in a different time frame.
The accelerated growth rate could also shorten harvest times, in turn alleviating damage caused by early winter frosts. There are also many other areas of agriculture and horticulture that could greatly benefit from the use of magnets.
We can look at the fruit industry, we can look at the flower industry, we can look at the vegetable industry, and most of all, probably the herb for medical application, which can be very expensive, very slow growing, such as the ginseng and other herbs. So we are very excited. We try to do many experiments.
Plans for a magnetically enriched fertilizer are in the works, as well as a magnetic seed mixer to be used before planting. But the use of these magnets may reach well beyond the Earth's limits. An even more interesting application may result in growing vegetables and plants in space.
If an astronaut wants to eat a fresh vegetable, because of space travel, you don't have a gravitational field to assist the plant to have an orientation of the flower growing this way or root growing that way. So in the absence of the gravity, we thought that the magnet can provide a virtual gravity, so to speak, so that you can pull the root growing one side and have a plant going, the leaf growing another side.
Chen is currently writing a proposal to NASA's Center for Microgravity Research, so these magnetic experiments can be further tested. Reporting for Eureka, I'm Erica Ingleson.
I was involved in a plant growth experiment conducted on board the Space Shuttle Atlantis in 1992. If exposure to a magnetic field enhances plant growth in space, a benefit might be the practical production of food for a space crew. That could, in turn, make interplanetary spaceflight more practical.